Welcome to this podcast. So again, we show you this in class, but I think this is worth repeating. And again, please pause me if you need to write these down. I want to talk about some of the biological challenges to classical conditioning. Again, just to review for you. So again, this is really, really important in the Garcia and Koelling studies, right? All of these, right? Put a check mark next to all of them. Garcia and Koelling seem to be challenging all of these assumptions that Pavlov was making about how classical conditioning happened. Now, this one's particularly important, the timing and the number of pairings necessary for acquisition to happen. So again, Garcia and Koelling connected to taste aversion studies. Those are showing the biological predispositions that organisms have that can affect classical conditioning. So I'm going to skip these. We already showed them. Okay, so what is this concept of biological preparedness? So we're going to back up a little bit, right? So we're going to start with kind of the results of Garcia and Koelling and other people's work, like the Brelands with instinctual drift. And this was the idea that natural selection predisposes us to learn certain behaviors, and that's the idea that learning is adaptive. All right? Learning is adaptive, meaning it helps us survive. Okay, so learning is adaptive. All right, that's even going to play into when we start talking about observational learning. So here's your definition of biological preparedness. Okay. The other thing, as we talked about in the earlier in class and on other vodcasts, is that biology sets limits to what we can learn. Okay? All right. And this is here. Okay. So in Garcia and Koelling's studies, interesting things happened. First of all, the timing, the CS and the US timing, seem to really, really contradict the assumptions that were made by Pavlov. Also, the pairings of different CSs or potential CSs, neutral stimuluses, with UCSs didn't work the way Pavlov predicted they would work, right? So if we look here, the inference is that basically loud noise and nausea are just not, the rat is just simply, like humans, probably not biologically prepared to very easily make that association. They just simply are not. However, they are able to make more easily. So this isn't always a question of either or. Sometimes it's a question of degree. Sometimes not at all, but often a question of degree. Sometimes the radiation happened upwards of 5 to 8 hours after they drank the water, and yet the rats would still avoid the water. And what happened was, this happened after one pairing. So after one pairing, the rats avoided the sweet water. Pavlov thought you had to have multiple pairings of the CS with the UCS for learning to happen. He also thought, remember, if we go back to this slide, he also thought you probably, this needed to come after this by half a second or so. If there was too much time, he didn't think the animal could make the association. And by the way, this happens to be accurate for many types of associations, but not for taste aversions. Taste aversions are different. So again, why would taste aversions be different? We think it's because of this. So again, it's that they didn't take into consideration the fact that biology plays a role here, and that certain learning is going to happen more quickly because it'll help the organism survive. Okay? So again, just keep these concepts in mind: biological preparedness, right? And the concept of taste aversions, right? And here's a definition of taste aversions.